Welcome to the deep dive. Okay, so you've given us this really interesting stack of sources, all focused on what looks like a pretty major shift in how software talks to itself, moving from basic data pipes to these intelligent software agents.
That's right. It's a fundamental change.
And we're going to zero in on why this tech leap is just, well, essential for what India is trying to do digitally, especially thinking about big projects like the National One Health mission.
Absolutely. That mission in particular really highlights the need for this new architecture.
So the goal for us today, our mission, is pretty specific. Let's get the term straight. We need to understand that, the huge gap between just accessing data and what you've called intelligence synthesis, where software can actually think and act.
Exactly. Intelligence synthesis, that's the core idea you need to hold on to. It's the jump from a system that just, hands over data when you ask,
Right.
to one that can proactively find the right data, assess it, and then act on it. All by itself, but crucially, while playing by all the rules, the governance, the privacy rules.
Okay, let's unpack that right away then. What's the fundamental difference, like structurally, between the kind of API developers have used for ages, the traditional ones, and this new thing, the Agentic API? And why is that difference suddenly so critical? Why is it something you just have to have for these big interconnected data systems India wants to build?
Well, to really get the new stuff, you got to look at what we're trying to move away from.
Makes sense. Start with the old way.
Right. So the standard API model, the one that frankly still powers a huge chunk of the internet, it's almost entirely built around this idea called CRUD.
CRUD, create, read, update, delete. Remember that?
Exactly. Those APIs are really good at one thing, manipulating resources, letting you get a user, update an order, delete a file. They tend to reflect the internal plumbing of the system, its data structure.
Okay, internal plumbing. So if they're focused internally like that, what breaks down when you try to get them to handle, really complex multi-step jobs automatically?
Well, it means they lack what we call operational intent, and they also lack semantic expressiveness.
Okay, I'll unpack those terms. Operational intent, semantic expressiveness.
Think about it like this. If you have an intelligent agent, maybe an LLM, trying to do something complicated, like, say, arrange an emergency shipment of vaccines,
Okay.
it can't just look at a basic API endpoint labeled POST order and figure out everything involved.
Yeah.
The full intent, the sequence of steps, the necessary checks, the approvals, none of that is clear from just post-order.
Ah, I see. So the LLM, acting as the agent, it wouldn't really know how to use the API properly for the goal. It knows it can post an order, but not the whole context, like transact, submit emergency request.
Precisely. The human developer, or maybe some really tightly connected code, has to manually string together maybe dozens of these low-level CRU calls.
Right.
And they have to interpret the result of step 1 to figure out what to do in step 2, and so on. The API itself gives you almost no clue about the bigger picture, the actual tasks the system can perform.
Okay, so that's the limitation. Now, here's where the big shift comes in. If that traditional API is just a passive pipe reacting mechanically, then an AI agent, this autonomous assistant we want doing complex stuff, it needs a completely different way to interact, a new language.
It needs an agentic API, an API for agents. And this is designed from the ground up to be task-oriented. The whole focus shifts. It's not about messing with low-level data resources anymore.
It's about
representing executable intent. The API now declares actions, things the agent can meaningfully understand and perform on its own.
And that new language, that structure, is defined by this action taxonomy you mentioned.
Yeah.
That's what replaces CRD.
That's the framework. Action provides that semantic clarity, the meaning, that agents need to actually reason about what they can do.
Okay, so break down action for us. What does it look like?
Well, it uses 6 main categories of operational verbs, much richer than just CRU. For instance, instead of just getty, an agent might see acquire. And under acquire, you'd have specific verbs like search or retrieve or maybe monitor. This immediately tells the agent, okay, this system's purpose here is about getting information.
That's already much clearer. What about more complex stuff? Like if the agent needs the system to actually process data.
That falls under compute. Think verbs like summarize, validate, translate, even predict.
Okay.
This is huge because the agent now knows if it calls a compute API, it's not just getting raw data back. It's expecting some kind of synthesized intelligence, some processed result.
Wow. Yeah, that gives the agent way more information about what to expect than just a generic POST or PUT.
Yeah.
And I guess you also need a category for, like, making a change stick. committing something.
Absolutely. That's transact. This covers those state-changing operations. Purchase, book, submit a claim, register something, things that have real-world consequences.
Makes sense.
And the last three, integrate, orchestrate, and notify, they handle the complex bits of connecting different data sources, managing multi-step workflows, and sending out alerts or logging events.
So integrate, orchestrate, notify.
Right. This whole set of verbs, this association taxonomy, lets an LLM agent look at an API definition and instantly grasp what the system can do, not just what data it holds. It's a completely different paradigm.
Okay, the solution Agentic APIs seems much clearer now. But if this is the answer, what was the original problem that got so bad we needed this whole new approach? You mentioned something traumatic.
The combinatorial hell, the integration crisis.
Combinatorial hell. I mean, that sounds bad. But isn't integrating systems just part of the job? Is it really a crisis? Or maybe just, tricky engineering?
It becomes a crisis because the complexity just explodes. Think about it. You have, say, 4 different government systems you want to connect. Point to point, that's 6 custom integration pipelines you have to build and maintain.
Okay, 6. Manageable, maybe.
But now scale that up. Imagine 50 different ministries or state health departments or environmental agencies. Suddenly, you're talking thousands of potential point-to-point connections, each one custom-built, fragile.
And fragile or brittle means if one system updates its internal stuff, its database schema or something.
Boom! All those custom pipelines connected to it just break. We call them brittle contracts. It's a maintenance nightmare.
Okay, I see the hell part now.
And it gets worse. Traditional systems usually rely on really basic static access controls. But think about sharing sensitive data like health records. You need dynamic, fine-grained consent that users can grant and revoke easily. Static permissions just can't handle that. It creates a permission nightmare. Traditional integration wasn't built for that world.
Right. Okay. This connects directly to the big strategic idea for a country like India. We keep hearing about the leapfrog strategy. How does dodging this integration mess fit that story?
It fits perfectly. India has this amazing track record of skipping outdated tech steps, right?
Like with phones.
Exactly. We didn't spend decades laying copper landlines everywhere. We jumped pretty much straight to mobile first. Huge advantage.
With UPI, Aadhaar.
Same pattern. Skipped the old slow banking payment rails and built UPI for real-time digital payments. Skipped waiting for physical ID cards everywhere and built Aadhaar for digital identity. It's about jumping over the inefficient middle steps.
So the argument is, let's do it again with data integration. Skip the years of pain dealing with brittle point-to-point APIs.
Yes. Especially because, let's be honest, a lot of public sector data sources are already fragmented, maybe not even fully digitized yet, instead of trying to force-fit them into the old, broken integration model.
Build the world's first agentified data infrastructure from the get-go.
That's the core idea, and the agent is the key. It acts as this smart intermediary. It achieves something really important, abstraction of heterogeneity.
Whoa, okay, hold on. Abstraction of heterogeneity, that sounds complicated. Break that down. How does standardizing the API for the agent stop us from having to standardize all those messy underlying databases in every single ministry? That sounds like the hard part.
It saves us because the agent is designed to handle the mess. Instead of forcing every single state department, every hospital, every clinic to use the exact same perfect data format, which, let's face it, is practically impossible administratively and financially.
Right. Never going to happen perfectly.
You design the intelligent agent to be the translator. It understands different formats. It can deal with inconsistencies. It bridges the gaps. And it exposes a clean, simple, intent-based interface upwards. You standardize for the agent and let the agent handle the complexity below.
Ah, okay. So it's like having a really smart multilingual librarian built into the system who knows how messy the stacks are but can always find what you need and present it clearly.
That's a fantastic analogy. And it shifts the whole process from just dumb data retrieval to what we called intelligence curation.
I heard it's curation. Okay.
Think about the principal scientific advisor, the PSA, needing high-quality data for national policymaking. Let's say they need data with very low uncertainty.
Right. High-stakes decisions.
A traditional API from, I don't know, the Maharashtra Health Department might just dump whatever raw numbers it has, regardless of quality or completeness.
But the agent acts like that librarian, like a curator.
Exactly. The agent knows the PSA needs, say, 85% data completeness for the analysis to be reliable. It looks at the local data and sees it's only 70% complete for that period.
So it doesn't just send the bad data.
No. It flags the issue. It might report back, This data doesn't meet your 85% threshold, it's only 70% complete for these reasons, and it might even suggest alternative sources or ways to cross-reference to improve reliability. A basic CRUD API just can't reason like that.
That ability to reason about context and quality, yeah, that sells the agentic approach right there. Okay, let's shift gears slightly. Part 3. What foundations does India already have that make this kind of leapfrog actually feasible? You mentioned the India stack.
Right, the India stack is crucial. It provides some really key building blocks, the foundational rails for this. You've got Aadhaar for identity, UPI for payments.
The basics.
But critically, for data sharing and trust, you have DP, the Data Empowerment and Protection Architecture, and the Account Aggregator Framework, or AAs.
Okay, DPay and AAs. How do they embody these agentic ideas, especially around privacy? That seems vital.
The AA framework, which really took off in finance first, is designed precisely for secure, user-controlled data sharing. It is agentic in its principles. It gets rid of horrible old methods like screen scraping.
Yeah, terrible.
And replaces them with digital consent tokens that are auditable, specific, and revocable by the user.
So if an AI agent wants my financial data, it can't just ping my bank directly. It has to go via the account aggregator.
Correct. And to do that, the agent absolutely must present a valid consent token that you issued specifically for that agent, for that purpose, for that period.
And if I change my mind?
You revoke consent through the AA system. That revocation is logged, and the agent's access is cut off immediately. It makes privacy programmable, trackable, enforceable. That's essential if you're going to trust autonomous software with sensitive data. And there's another privacy win here. Agents allow for computation near the data. Instead of hauling massive sensitive data sets across networks, which always increases risk, an agent can potentially perform analysis, like applying anonymization or differential privacy techniques at the source.
So it only shares the necessary insight, not the raw, risky data itself.
Exactly, minimizing data exposure.
Okay, this brings us right back to the big vision, the National One Health mission. Integrating human health, animal health, environmental data. Trying to spot the next outbreak early. You've got the Ayushman Bharat Digital Health Mission, ADDM, with its health IDs, ABHA, acting like the AA for health data.
That's the goal. ADDM mirrors the AA consent model for healthcare. And the alternate One Health dream is that truly agentic scenario, seamlessly weaving together human health data via ABDM, veterinary data from places like Naveti, maybe climate and environmental data.
All talking the same language?
So an agent can reason across them. The committee looking into One Health specifically saw the need for agentic systems because you simply cannot achieve that level of cross-domain intelligence synthesis with old-style brittle connections.
But what's the piece that's still missing? You mentioned cross-domain integration is still nascent. What's the structural gap we need to fill?
The main hurdle right now is the lack of a truly universal query layer and the associated semantic standards that work across different sectors. Meaning today, an agent trying to assess one health risk would still have to talk to the health consent manager using its specific API, then figure out a totally different API for the animal data system, then maybe another standard one for weather. It's still jumping between different silos, different API languages.
Siloed intelligence.
To get true One Health intelligence, we need that universal layer that understands intent regardless of the domain. An agent should be able to ask something like, acquire, zoonotic risk profile for disease X in region Y, and the layer figures out how to get the necessary inputs from health, animal, and climate systems, synthesizes the answer, and returns it, all using one consistent execution-based approach.
Got it. So wrapping this up, this deep dive really makes it clear that agentic APIs aren't just some incremental tech upgrade. They feel like the necessary evolutionary step, moving India's digital infrastructure from just connecting data silos
to actively turning them into these adaptive, context-aware intelligence generators.
Yeah.
The whole game changes. It's shifting from just retrieving bits and bytes to actually generating synthesized intelligence. By adopting these agentic API principles, focusing on clear intent, making sure actions are understandable, and building on the India Stack's governance, India is really creating a potential blueprint for how you do massive digital transformation while keeping trust and privacy front and center.
Okay, so let's leave our listeners with that final thought experiment. Think about that zoonotic disease detective scenario you sketched out.
Right.
You've got autonomous agents coordinating across ministry lines. An animal health agent flags weird symptoms in livestock. It talks to a human health surveillance agent. It pulls in climate data about, say, mosquito migration patterns from another agent. And together, they synthesize a high-probability risk report for policymakers. Not in weeks, but maybe in minutes or hours.
How does that capability, that speed, that precision, driven by trusted, autonomous, agent-based coordination working off verified intent, how does that fundamentally alter how quickly and effectively we can respond to the next pandemic threat? We'll let you chew on that one. How much faster could we be next time?